The graph shows the position vectors OX and OY. And so here we have the position vector OX, and here we have the position vector OY. Now here they want us to write down the column vectors for OX and OY. First, let's figure out the coordinates of the point X. So X is right here, right? And the coordinate of X is going to be, well, we have a -1. So that's -1, all right, comma, and then we have 4. So -1, 4, that's the coordinates of X. So X, if we were to write it in terms of coordinates, X is equal to -1, comma 4. That's the coordinates of X. Now let's determine the coordinates of Y. So as you see this color, so Y is going to be right here. That's the point Y. And Y is 5. So that's 5 and comma. If we go across, this is 3. So 5, 3, right? So the coordinates of Y is equal to 5, 3, 5, comma 3, 5, comma 3. And so what do we have? Well, we have that X, the coordinates of X is -1, 4, right? That's the coordinates of X. And the coordinates of Y is 5 and 3. And so these are the coordinates of X and Y. Now, in order for us to write down OX as a column vector, all we need to do is we need to take the coordinates of X, and instead of writing it horizontally, we're going to write it vertically. And so we put -1 and 4. And so that's OX written as a column vector. Now for OY, we do the same thing. Instead of writing the coordinates horizontally, we're going to write it vertically. And so it's 5, 3. So the column vectors OX and OY are the following. OX is -1, 4, and OY is 5 and 3. Okay, next we need to express XY as a column vector. So XY is going to be equal to XO plus OY. And that makes sense because let's go here. If we're trying to go from X to Y, well, the first thing that we have to do is we have to go from X to O, right? We have to go from X to O. That's the first thing. You have to go from X to O. X to O, that's the first thing. And then the second thing you have to go from is O to X, right? I'm sorry. The first thing you go from X to O. And the second thing that you go is you go from O to Y, O to Y, O to Y, right? So XY is going to be equal to X to O, right? First, all right? So we go from X to O, and then we go from O to Y. So X to O, and then O to Y. Okay, next, what we're gonna do is we have XO here, and we have OY. Now, if we go back in our previous question, in our previous answer, we know what OY is. That's fine. OY is just 5, 3. But the problem is we don't know what is XO. We don't know what is XO. Now, what we do know is we know what OX is. So OX is -1 and 4. That's what OX is. But we don't know what XO is. So what we have to do is we just have to switch the letters. And that's because we know what OX is. So if we just switch the letters, then we could be able to substitute. So here we have XO, but instead of writing XO, I'm going to write OX. And the reason why I'm doing that is because I know what XO is as a column vector. I don't know what, I'm sorry. The reason why we're doing this is because I know what is OX as a column vector. I know what that is. We know what that is explicitly, but I don't know what XO is. Okay, so hopefully I'm clear this time. I know what is OX as a column vector, but I don't know what XO is as a column vector. So I switched the letters because I could substitute OX, but I don't know what XO is. And we keep OY. Now the thing is, notice that I have a negative sign here. Now the reason why I have a negative sign is that whenever you are switching the letters, and you can do that, that can work. That's correct. You can switch the letters. It's no problem. There's no problem with switching the letters. The only thing that is that there's a penalty that goes along with switching the letters. If you're going to switch the letters like we did here, you have to put on the negative sign. And so XO is going to be equal to negative OX. And you put on a negative sign because that's the penalty of switching the letters. So we have a negative OX plus OY. What is OX? Now we could substitute, right? So what is OX? OX is -1, 4, and OY is 5, 3. We say -1 multiplied by -1. That gives us +1. We say -1 multiplied by 4 gives us -4. And we just bring down the 5 and 3. Now we're going to add these two vectors. We have 1 plus 5, and 1 plus 5 is 6. And then we have -4 plus 3, and -4 plus 3 is equal to -1. So xy is equal to 6 and -1. Okay, so we already expressed xy as a column vector. Now we need to go and figure out what is the magnitude of OY, the magnitude of OY. Now what is OY, right? But even before we figure out what OY is, let's write down the formula, or let's look at this formula for the magnitude of a vector. So if you have any vector that's a column vector with two components, all right, x and y, well, in order for us to find the magnitude of this vector, we have to take the x component and square it, to take the y component and square it, add those two, and then take the square root of our answer. And that's what the magnitude is equal to. And so what we're gonna do is, if we have OY, well, OY is equal to 5, 3. That's what OY is. That's what OY is as a column vector. So we take the 5 and square it. We take the 3 and square it. And so what is 5 squared? Well, 5 squared is 25. 3 squared is 9. And so we add these two, 25 plus 9, and 25 plus 9 is 34. So the magnitude of OY is equal to the square root of 34. Let me take the square root of it. When we take the square root of 34, we get 5.830951895. But we want to answer correct to two decimal places. So we look at this 0. And since it's less than 5, that means that we can keep these numbers the same, unchanged. And so correct to two decimal places, the magnitude of OY in this question is 5.83. And that's the answer to this question.